All right, so this is day 2 of Algebra 2's 412. So we're going to be taking a look at a few more things here. Let me pull up this. And to start off, we're going to look at this problem. So we're going to have a right of 2x plus 3 is equal to x. So we're going to solve it out algebraically. So we pull that up. So we have square root of 2x plus 3 equals x. So fairly straightforward to solve this out. So go ahead, pause it, and try and solve this out pretty briefly, and then come back here. Okay. So what we likely did was just squaring both sides to get rid of this big radical, right? And we get 2x plus 3 equals x squared. Awesome. Well, now I have an x squared and an x. That's a quadratic. So I can solve that by getting everything on one side and then factoring it. So I'm going to make this 0 is equal to x squared minus 2x minus 3. So what multiplies to be a negative 3 and adds to be a negative 2? Well, that's going to be x minus 3 and x plus 1. So then that's factored. So now using the zero product property, I get that my x is equal to 3, but also negative 1. So I got two solutions here. And that's great. Well, one thing that we talked about last time that we can do is we can answer these problems by graphing it. So I'm going to go ahead and pull up Desmos, and we're going to solve this by graphing, right? So I'm going to graph the left-hand side, which is the square root of 2x plus 3, and the other side is just x. And I get this. So I see I have my answer right here at 3, right? But I'm not seeing that negative 1 answer that I got doing it algebraically. So what's the problem there? Let's hop back over to this. So we did nothing wrong algebraically at all. This is entirely valid and fine algebraically. But there's one little thing that kind of messed us up, and that's the very first step, right? There's nothing wrong with doing it, but it does cause this kind of little extra bit here, which seems to not actually work. Well, let's try this and see what works. If I plug in 3, I get the square root of 2 times 3 plus 3 equals 3. So that's going to be 6 plus 3 is 9. Rad of 9 is 3. I get 3 equals 3. It works. Great. What if I plug in a negative 1? Square root of 2 times negative 1 plus 3 equals negative 1. Well, that's going to be negative 2. That's going to be 1. Rad of 1 is 1. I get 1 equals negative 1. That is not true, right? So the negative 1 does not actually work. So the reason why there is a problem here is these two statements are not equivalent. Okay. The reason is because this would give me a different graph than this one, right? Basically, if this was plus or minus, it would be fine, right? But when I go and square it, that whole deal with the radical and a plus or a minus goes away. So I've kind of inadvertently added an additional solution. Another way to look at it is my largest power here is x. I should only get one answer if my largest power is x. Now we can have two answers in this situation, but more than likely we're going to have one. So let's go ahead and look back at Desmos and see what's happening here. So if I were to actually graph that other portion here, which would be this same thing but negative, let's just copy paste it. The other answer that I end up seeing here is that negative 1, right? So when I square both sides, I could be using just the positive one, or I could be using just the negative one, or I could be using both. And my algebra doesn't really know which of those three options I am doing, so it just follows the math, and it gives me both answers. So what we have here is what's called an extraneous solution. This negative one, which doesn't work, but we still got it by doing correct algebra steps, is an extraneous solution. Now, you technically should check every single algebra problem you ever do, but the ones you definitely want to be checking are anytime you are squaring both sides. That's by far the most common place to see these extraneous solutions appear in our problems. All right, let's hop back over here. So discovered that. Awesome. All right, so let's take a look at number 18. So this is going to cover another kind of type of problem. So we're trying to solve 2x squared plus 5x minus 3 is equal to x squared plus 4x plus 3. So we can solve that, like we said last time, by graphing the left-hand side, graphing the right-hand side, and finding where those are. So finding where those intersect. They are saying that, what's his name? One of their teammates, Gustav, graphed this. And then they saw that and like, why is he graphing that? Well, let's go through the kind of problems here. So how many answers do we predict we're going to have? Well, these are two quadratics, so we need two parabola graphs. So they could never touch. That's not very likely because they are both positive, so more than likely they're going to touch, but it is possible for them to never touch. They could touch once or they could touch twice. It all just kind of depends on how they are oriented. So I know those are my kind of options there. So let's go ahead and solve this with Desmos by graphing these. All right. Pull up Desmos. Let's get rid of these. So we said that the first way that we can solve it is by graphing 2x to the second plus 5x minus 3, and then also graphing x to the second plus 4x plus 3. So if I graph those, I see I have one answer here, and then if I scroll up a little bit, I should see my other answer right there. So there's negative 3 and 2. Again, my x values are my answers, not the entire point. Yeah. So those are my two solutions that I got by doing this on a graph. Now, they said that they graphed x squared plus x minus 6. Now, why would they do that? Well, let's check that by doing it algebraically here. So you hop over to my document camera. If I want to do this algebraically, they have 2x squared, get my better pen. There we go. 2x squared plus 5x minus 3 equals x squared plus 4x plus 3. So we're going to gather everything on one side because if I have a quadratic, I have to get it equal to 0 in order to solve it. So minus that, and I get x squared. Minus that, and I get plus x. Minus that, and I get minus 6 equals 0. And that is what they graphed. They graphed this. So you could just graph this and then look at where it is 0, which is the x-axis. Well, let's give that a shot. So if I go back over here, and I now graph x to the second plus x minus 6, see where this one crosses. It's 0 at negative 3 and positive 2, which is the exact same answers I got the last time, which hopefully makes sense because I'm graphing the same thing, just I put it all on one side and looked at where it's 0 versus leaving it as two separates and finding where those intersect. They both should give us the same solution. And then if I want to go through and do this one algebraically, not too bad. I'm going to factor it and figure out, hey, what multiplies by negative 6 adds to 1? Well, that's going to be positive 3 and a negative 2, which would be x equals negative 3 and a positive 2, just like we found by graphing it, right? So no big deal there. All right, hop back over here. And that is going to be it for day 1. So doing 22 through 28, and I'll talk to you guys next time.